Okay, so in the last video, I had some examples of graphing rational functions. Now, I just want you to practice simplifying them, and I'll show a graph afterwards just to get an idea of what this thing looks like. So, when you're trying to simplify rational functions, factoring is your friend. So, look back at all those factoring videos and activities I posted, I think about 2 weeks ago, if you want a review on it. But we're going to be using those factoring properties as we go through these. Now, just like if you had a fraction, let's say you had 4 over 8. You would divide top and bottom by 4 to simplify it. The same thing happens when you're working with rational functions. And again, a rational function is a polynomial over a polynomial. If they have the same exact thing inside both, at least part of it, like x plus 5 in top and bottom, you can go ahead and simplify it and take it out. However, if you are able to cross something out from top and bottom, that is called a hole, meaning at that part on the graph, it will show up as a gap. Nothing else will be present there. I'll give an example of that when we finish the first question. So for this one here, we want to go ahead and simplify it. And I just noticed that there was actually a typo. This question should have started with an x. Otherwise, there's really nothing exciting going on. So I'm going to go ahead and put that in here and also fix the copies that I post online. So let's pretend it started with 4x over x times the quantity of x plus 2. Okay, so I am going to go ahead and cancel out that x because I'm simplifying. I'm dividing top and bottom by x. That x is gone, that x is gone. What I would then be left with is 4 over x plus 2. So that would be my simplified version of this answer. Now for these questions, they want me to identify the domain. So basically everything that's not the asymptote, and also identify the hole. So again, a hole is that part that I canceled out. So I'm going to go ahead and write it this way. D for domain, and that is going to be everything except x can't be negative 2. So x is not negative 2, but also do note that I crossed out the x. It's not going to be 0 either. So it's not negative 2, and it's not 0. So I'm listing those values. But in particular, the hole is 0. So again, the domain, it's everything that's not negative 2 and not 0. And it just so happens that when x is 0, that's a special thing called a hole. I'm going to go ahead and show you a graph of this exact question. Okay, so here's an example of a graph. Notice that the red lines, so this up and down here and left and right, those are the asymptotes. So this red line here represents the x equals negative 2, our vertical asymptote. And notice that at x equals 0, there's a hole there. So this graph is continuous in this portion, except for when x is 0. All right, in question B, we have x plus 4 over x squared minus 16. What you want to recognize is that the bottom of that, x squared minus 16, is a difference of squares. Let's go ahead and refactor that. X plus 4 over x plus 4 times x minus 4. Remember, when it's a difference of squares, you have the square root of the first term, which is the x, square root of the last term, so square root of 16 are the 4s. One's positive, one's negative. Okay? Notice that top and bottom both contain x plus 4. So go ahead and cross those out. Write what you're left with. Okay? So this equals 1 over x minus 4. Okay. Let's go ahead and identify the domain. So D for domain. And this is saying x is everything but not 4 and not negative 4. So in this example, we cannot have 4. Again, 4 minus 4 would get us 0. And we can't have negative 4 because negative 4 plus 4 would get us 0. And out of those values, we do have one hole, the one that was canceled out. So we have a hole at x equals negative 4. And I'm going to go ahead and pull up that picture. As you can see here, we have the x asymptote, the y asymptote, and there's the whole at -4. All right, so for question C, we have x squared minus 4x minus 12 over x squared minus 4. Now we can see that the bottom is going to be a difference of squares. The top part is probably going to be a regular trinomial. Let's go ahead and see if we can factor it. So take a look at A times C. So 1 times -12 is -12. I need to find two things that are going to multiply together to get me -12, but sum to get me -4. So I come down and I think about 1 and 12. Not going to work. I think about 2 and 6. That will work. If I make the 6 become negative, and again, I know it's not showing up too well. I'll show it over here. If I make my 6 negative, 2 minus 6 gets me that -4. So again, this one up here is going to become x minus 6, x plus 2, all over. And again, that bottom one is a difference of squares. X plus 2, x minus 2. Notice that I have x plus 2 on top and bottom. Okay, so those are gone. We can go ahead and rewrite it. This is x minus 6 over x minus 2. So that rational function has been simplified. And again, with these here, I'm not actually asking you to solve for that rational form. Remember on that first lesson, we talked about getting it into a over x minus h plus k. I'm not looking for that right now. I just want you to simplify this. If they have factors in common, take them out. Which means we're now ready to list domain. So my domain, I take a look at the bottom, and again, when I'm doing this part, what I check for is whatever I crossed out and whatever is in the bottom. The top doesn't matter at all. What's in the bottom is what affects your ability to actually plug stuff in because you can't divide by 0. So I'm checking the bottom only, not the top. So if I set this equal to 0, x can't be 2. So x cannot be 2. If I take a look what I canceled out, it also can't be -2. And out of those choices, I had a whole, and the whole was at the -2. Let's pop over to the graph and see what that looks like. Here is that third graph. We see that we have a y asymptote and an x asymptote, and here is the whole. Okay, let's go ahead and take a look at D. We have x squared minus 2x minus 3 over x squared minus 1x minus 6. Let's see if we can go ahead and factor that. I'm going to do the top one first. So I'm looking at a times c. So 1 times -3 gets me -3. I need something that multiplies to get me -3, but sums to get me -2. Notice that if I use -3 and +1, when I add them together, I will get -2. So for the top then, I have x minus 3, x plus 1. Do the same thing for the bottom. A times c is -6. I need two things that multiply to get me -6, but sum to get me -1. Well, I can use -3 and +2. -3 times 2 is -6. -3 plus 2 is -1. So on the bottom, x minus 3, x plus 2. Notice that both of them have -3, so I went ahead and I simplified that, which means this can be rewritten as x plus 1 over x plus 2. Okay, so that would be my end answer for this question here. Now my domain cannot be -2. Again, I don't care about the top, only the bottom. So my domain is x as everything but not -2. It's also not what we crossed out. It's not +3. And from all this work, we know that there's a whole at x equals 3. Let's go ahead and take a look at that graph. All right, so here's the graph. We can see the x asymptote up and down, the y-asymptote left and right, and exactly there, at 3, we see the hole. Okay, so for E, we have rational functions being multiplied together. We have 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. So we're going to want to go ahead and factor the stuff that we can and then see what's going to cancel out. So looking at this first set here, notice that both of these parts contain a 3x. So I can come from this and say that I have 3x times 1 minus x. And again, you can go ahead and check the work. 3x times 1 is 3x. 3x times negative x is that negative 3x squared. Over, so this bottom one, and we can do the notes over here. Notice that a times c is negative 5. I need two things that multiply to get me negative 5, but sum to get me positive 4. That can be 5 and negative 1. So over here, I'm going to have x plus 5 and x minus 1. Let's come over to here. A times c is negative 20. I need two things to multiply to get me negative 20 that sum to get me 1, because again, x is just 1x. Well, that gap is 5 and 4. If I make my 5 be positive and my 4 become a negative 4, this will work. My top is x plus 5 times x minus 4. My bottom is that 3x. Now, I'm going to cancel out some things now, and when we do this, it might be useful to keep track over here over what we're doing. So first, I'm going to cross out the 3x's. Now think about what we just did. If I took 3x and set it equal to 0, means the whole is happening at 0. So let me make a note of that. One of the holes I've found so far is at 0. Let's do this again with x plus 5. See one on top and bottom. If I were to set this equal to 0, x cannot be negative 5, which means I have a hole at negative 5. Let me rewrite what I have so far because we're not done yet. So I have 1 minus x minus 4, and I have x minus 1. Notice that something here looks very similar. These two look almost identical, but the minus sign is flipped. I'm going to show you a trick. When you have the same values, so 1 and x, the only thing that switched is the sign for both parts. Like this was a positive 1, that's a negative 1, that's a negative x, that's a positive x. Take out a negative sign. I'm going to take out a negative sign from the top. So I'm going to take out a negative. I'll be left with x minus 1. Don't believe me? Check it. Negative times x is negative x. Negative times negative 1 is this positive 1. I then have x minus 4 and x minus 1, and now I can tell that those things do cancel out. So I'm going to go ahead and cross off those x minus 1s. Which means I have another hole at 1. Now remember, when I'm finding these holes, I'm taking the part I crossed off, make that more obvious. That's what I crossed off, and I'm setting it equal to 0. So x minus 1 equals 0 means my hole was at 1. So this in simplified form is just x minus 4. And my domain, well, it happens to be the same thing as the holes. I can't have any of these values. So I cannot have 0, I cannot have negative 5, I cannot have 1. But there's no asymptotes, just holes. Let's go ahead and take a look at what this graph appears as. Let me actually make a quick note here. We have a negative sign in front of all this. This should be negative x plus 4. I lost the negative. So negative x plus 4. Now let's go ahead and graph it. All right. So because our equation was negative x plus 4, that's actually just a straight line. So remember, negative x means I have a slope of -1, so down and right, down and right, down and right, forever and ever. And my y-intercept is at 4. However, I have a hole at 0. I have a hole at 1. And I have a hole at -5. So it's a straight line except for those 3 holes. Unlike the other ones, you don't see those hyperbolas, those bends in the rational function, because when we simplified this one, the x's were only in the top. It was just a linear function. There was no denominator with an x in it anymore. Okay, let's take a look at question F. I have 4x over 5x minus 20 divided by x squared minus 2x over x squared minus 6x plus 8. So we're going to want to go ahead and factor these parts, and also notice that this division, well, dividing by a fraction is the same thing as multiplying by the reciprocal. We're going to flip this thing upside down. It doesn't matter when you do it, although to make this maybe easier to remember, I'm just going to do it first. Although when you do it is entirely up to you. So what I'm rewriting is that I have 4x on top. On the bottom, I'm actually going to factor this part right now. They both have a 5 in common. Take it out. 5 quantity x minus 4 times, and now I'm going to go ahead and just flip this upside down. Now remember, when you're dividing by a fraction, the one that flips is the second one, not the first. So I have x squared minus 6x plus 8 on the top, and x squared minus 2x on the bottom. Now let's go ahead and continue factoring. So again, I have 4x over 5 quantity x minus 4. In the bottom here, they both have x in common. Let's take it out. X parenthesis, x minus 2. Let's go do the top part now. A times c, 1 times 8, is 8. I need something that multiplies to get me positive 8, but sums to get me -6. That will be -2 and -4. So over here, I have x minus 2, x minus 4. All right, let's go ahead and get ready to cross stuff out and track our holes as we go through this. So I'm going to start by crossing off the x's here. So those x's are gone, which means I have a hole at x equals 0. And again, when I'm finding a hole or a vertical asymptote, whatever you're looking at, set it equal to 0, solve for x. So x equals 0. For my next thing, I notice that I have x minus 2 and x minus 2. If I set them equal to 0, I have a hole at positive 2. And lastly, notice that I have x minus 4 and x minus 4. If I set them equal to 0, I have one at 4. Let's go ahead and write what we're left with. X, the 2's, the 4's, all I'm left with is a fraction. 4/5. A pure number. So essentially, I'm graphing y equals a number. That's a horizontal line at 0.8 because 4/5 is the same thing as 0.8. If you want to see that, 4 divided by 5 is 0.8. Okay, so let's go ahead and name the domain right now. So those are my holes, and my domain happens to be everything that's not 0, 2, and 4. Let's go ahead and take a look at that graph. Okay, so notice that when I graphed that line, it was horizontal at 0.8 with the holes of 0, 2, and 4. And again, because this whole thing boiled down to just a number, it's purely a horizontal line. No weird other shapes, no slopes, just slope of 0, horizontal.